Now it's time to start programming. In this section of the DVD, we're going to cover the basic building blocks of HLSL, data types, structs, and functions. In this chapter, we'll start with data types. If you're already familiar with programming in C, you can probably skip this chapter. Otherwise, let's open up Effects Composer. The very first thing you need to know about writing shaders is that you should never start from scratch. Always find another shader that's similar to the one you want to write and go from there. All shaders have a lot of code in common, so starting with a completely blank page is a real waste of time. You can save yourself a lot of typing and a lot of potential problems by starting with a shader that already works. Let's do that now. We'll load up the shader in Chapter 4 on the DVD. So we'll browse to Chapter 4 on the DVD and open up Chapter 4 shader.fx. This shader is really simple, but it's a good place to start learning. Let me just start by saying in the next chapter, I'm going to explain what each of these sections of the shader is. But just for now, don't worry about what all this other code is. Just jump right here to the middle of the vertex shader, and this is where we're going to start learning. Let's start out by talking about data types. The main type of data in HLSL is called a float. A float is just a floating point number, which means it can go very high in either the positive or negative direction. Let's make a float here. We'll just type float bob equals 1.5. So there we go, our first line of HLSL code. In this line of code, float is the type of data we're creating, and bob is the name that we're giving to our data. 1.5 is the value that we're storing. All lines of code must end with the semicolon. So what does this line do? Well, we've just created a container and put something in it, basically. Float is the size of the container, bob is the name of the container, and 1.5 is the value that we're putting in the container. Pretty simple. Now let's do something else. How about float Fred equals Bob. This line makes a new float size container named Fred and puts the same thing in it that Bob has, 1.5. Now let's do some simple math. Let's do float Tom equals Bob times Fred. So any guess about what float Tom is? Yep, it's 2.25. And the reason for that is because we're multiplying the value of Bob by the value of Fred, and both Bob and Fred are 1.5. So 1.5 times 1.5 is 2.25. So Tom now holds the value 2.25. Now let's make a new type of container. This one's a double wide. We'll call it float 2. Float 2 is a pair of floats, so it can store two numbers. Here's how to create a float 2. Float 2 Charlie, give it a name, equals float 2 0.5 comma 2, and we'll end with a semicolon. That's a little more complex. We had to give Charlie two numbers to hold, and we defined them as a float 2 by saying float 2 0.5 comma 2. So now float 2 Charlie is holding our two numbers. Float 2s are very good for holding things like UV coordinates, since UV coordinates have two values, a U value and a V value. So in this case, if this were UV coordinates, our U value would be 0.5 and our V value would be 2. Alright, let's do some more math. Let's do float 2 Joe equals Charlie times Bob. How does that work? We just multiplied a float, Bob, times a float 2, Charlie. Well, Bob's value is multiplied by both of Charlie's values. So Joe now equals 0.75 and 1. A float times a float is always a float. A float 2 times a float 2 is a float 2. A float times a float 2 is always a float 2. And that's why when we said when we created Joe, we made him a float 2, because the result of a float 2, Charlie, and a float, Bob, is a float 2. But what if we only want to multiply Bob by one of Charlie's values? Well, here's how we do that. This time we're going to call it a float, because the result is just going to be a float. So we're going to say float Ted equals Charlie dot x times Bob. Now what's going on here? Well, we know Charlie is a float 2. If we only want to access one of Charlie's 2 values, we can use a dot x or a dot y. So in this case, Charlie dot x equals 0.5. And so Ted is going to be equal Charlie dot x, or 0.5, times Bob, or 1.5. So we add the dot x to the end of Charlie to tell it that we want the first value. If we wanted the second value, 2, we would add a dot y. You can also use dot u and dot v. So let's do another example. How about this? Float 2 Tim equals float 2 and some parentheses, Bob, Charlie dot y. So now we've got a new float 2 that contains the value of Bob for its first number and the second value of Charlie for its second number. So Bob would be 1.5 and Charlie dot y would be 2. So float 2 Tim is 1.5 and 2. Alright, let's do one last little trick before we move on. This one's called a swizzle. Here it is. Tim dot xy equals Tim dot yx. So can you guess what it does? Yep, it swaps the order of the components in Tim. So Tim used to be 1.5 and 2, and now it's 2 and 1.5. So we swap the order. Pretty cool. The next data type is a float 3. It's just like a float 2, except it has 3 slots in it. All the same rules apply that we've already talked about apply to float 3. So you create a float 3 like this. Float 3 John equals float 3 Tim dot y Bob and Charlie dot x. You can multiply a float 3 by another float 3, or you can multiply it by a float. But you can't multiply a float 3 by a float 2. So you can do this. Float 3 Todd equals John times float 3 Charlie Fred. Okay, so we made a new float 3 named Todd, and Todd is equal to John times another new float 3, which contains Charlie. Now Charlie's a float 2, so we're grabbing both of Charlie's values, 0.5 and 2, and putting them in here. And Fred. Fred is the same as Bob, remember. So now we've got 0.5 and 2 and 1.5 times John, which is, this is getting a little complicated, 2 and 1.5 and 0.5. The neat thing about using all these variables is the computer just keeps track of it for you. So you can make as many variables as you want and swap them all around and play with them as much as you want, and the computer just gets it all right, and you don't have to keep it straight at all. So here we're multiplying a float 3 by a float 3, and the result of that is a float 3. And for an example of something you can't do, you can't say float 3 Todd equals John times Charlie. We can't do this because Charlie is a float 2 and John is a float 3, so that's invalid. And if we try to, let's just get rid of this line really quick. And if we tried to save this, it's going to complain and say, whoops, we made a little typo here. So I'm just going to fix that really quick. If we save it, it's going to say cannot implicitly convert from float 2 to float 3. So it's trying to multiply a float 2, and a float 3, and you can't do that. So let's just undo this, get back to our good line. And if we save this, now everything's fine again. That works. So you can swizzle a float 3 like this. Todd dot xyz equals Todd dot zyx, or you can say Todd dot xyz equals Todd dot xzy, etc. You can put the components in any order you want when you're swizzling a float 3. Float 3s are good for storing vectors. A vector is a line, like a surface normal or the line from the light source to the surface. Vectors have 3 components, so float 3s are just right for storing them. Float 3s are good for storing colors. Since colors have an R, a G, and a B value, they fit into a float 3 just right. In fact, for the components of a float 3, you can also use R, G, and B. So if you want to get the second component of Todd, you could just say float Larry equals Todd dot G. So G is the second component because it goes RGB. And if you wanted to, you could swizzle Todd like this. Todd dot RGB equals Todd dot GRB. So you can use XYZ or you can use RGB, whichever is the most convenient. Finally, you can also use a float 4. A float 4 is just like a float 3, but with one additional value. It's good for holding a color that has an alpha value, for example. Everything that we've talked about so far with float 3s also applies to float 4s. So those are the main data types in HLSL, or at least the ones we're going to talk about right now. There are others as well, like int, bool, and matrix, but we're not going to cover those right now since we won't be using them much for the shaders on this DVD. Now, one thing that I want to point out before we go on is every time we've typed float or float 2 or float 3, can you notice how it's turning it blue? What that means is that this is a word that FX Composer recognizes. And the nice thing about that is if you make a typo and you type something like flout, it won't turn it blue, and so you know that that's not correct, and that if you save it, it's going to give you an error. So that's one of the handy features of FX Composer, and that's one of the reasons we use FX Composer instead of just Notepad, because it has that nice color markup so that you know when you're doing things correctly. Alright, now that we've covered floats, float 2s, float 3s, and float 4s, let's apply what we've learned so far and actually create some workable shader code. The first thing that I'm going to do is type return, wait a second, nope, I already got that. So right here it says return out, and out is the value that we're going to be calculating in the end. So what I'm going to do is I'm going to type out.color equals, and we're going to cover what this means in the next chapter. But we're going to say out.color equals float4, and let's figure out some values to give it. How about Charlie.x, which should be 0.5, and what else? We could say, how about let's just give it a hard-coded value, 0.2, and we could say Todd dot z, which would be the same as Fred, and how about let's just give it 1.0. Okay, so now we've set our output color to 0.5, 0.2, 1.5, and 1.0. And if we save it, it's going to give us an error. And let's see, find the error. Ah, I see it. We typed float3 here without assigning it to anything, so we'll just delete that really quick and save. And it compiled correctly. And up here we can see this nice purple color. Let's see what happens when we assign this shader to our object in Max. So we'll switch over to Max. Make a teapot really quick. Bring up the material panel. Pick DirectX 9 shader. And browse to the DVD. Chapter 4, assign the shader. And we don't have any parameters to edit it, but let's just assign it to the teapot. We got this nice purpley colored teapot. Let's just have some fun with that. We'll scoot the Max window over and scoot the Effects Composer window over a bit. And let's say 0.5 and 0.1. See what that gives us. Save. And now it's kind of a red color. Alright, let's do one more. Let's do 0.3, 0.6, 0.2. Save. And it updates. And now it's kind of a green color. So you can see that I've created this float4, which is the R, the G, and the B value, and then the alpha value at the value of 1. So I have complete control over the color of my teapot by assigning this float4 color value here. So that's it. We've covered the most basic building block of HLSL, data types. And we talked about the most commonly used data types, float, float2, float3, and float4. We discussed how these data types can be combined and swizzled, and we did some sample math with them. Finally, we applied what we learned by creating a sample shader that sets an object's color. In the next chapter, we're going to look at another building block of HLSL, the struct. Finally, we'll round out this section of the DVD by talking about functions and function calls in Chapter 6.